Hey everybody, it's Mr. Carr again. Today we're going to be looking at 2.2 day one. This is going to be taking some of my information and we're going to use that to write quadratic functions and models. Okay, so sometimes we just have like some basic information like this. Write an equation of a parabola given the vertex and a point on the parabola. Now, since I'm given vertex like this, I want to start with vertex form. Maybe a problem is going to have you change it into standard form, and that's possible. But for this problem, I'm just going to start with this. Look at what I have here. I have H and K. Okay, that is my vertex. So that's going to go into this form and look like this. It'll be A times x minus 1 squared plus a negative 2, or just minus 2. All I did was fill in this H and this K with this 1 and negative 2 here. But now I need to know what the A value is. I don't know if there's a stretch or compression or anything like that. My point is just a point that's on the graph, so it's x comma y. Well, we've done something similar to this. If I want to find A, it'd be nice if I know an x and a y value, which I do. So I'm going to take 2 and replace the y. 3 is going to replace the x. So it looks like that. So now I can go through and solve this out for A. So if I look at my order of operations, I'm going to start with 3 minus 1 here. That's going to be A times 2 squared minus 2. If I square that, that's going to turn into a 4a, so that'll be 4a minus 2. So we can add 2 to both sides here, so that 4 is equal to 4a. Finally, I divide by 4. So that gives me 1 equal to a. So I have everything I need now. My equation here, my parabola, is going to be y is equal to 1 times x minus 1 squared minus 2. Okay, that a little bit better, minus 2. Now, just like we did before, if you wanted to, you can take this and transform it into standard form. So we're going to do that by doing x minus 1. So I'm going to write that down. This is my vertex form. If I turn this into x minus 1 times x minus 1, I'm going to distribute that one. So multiply those right there. So it's x times x is x squared. And then I have a negative 1x and a negative 1x. So it'll be a negative 2x. And then negative 1 times negative 1 is positive 1. Minus 2 like that. So then I can do x squared minus 2x and then put these together to get a negative 1. This is my standard form. So just showing you how to take that vertex form, turn it into standard form if you want that one. Write the equation of this parabola shown. Similar idea. We just need 2 pieces of information. We're just shown on a graph instead of being told what they are. I need my vertex, which is right here. And then I need just an x and a y, which is right here, the negative 4 and 13. So if I do this as y is equal to a times x minus a negative 1, so it's going to turn into a plus 1 squared. And then minus 2 stays, not minus 2. Let's plug in the x and y here. So 13 is equal to a times negative 4 plus 1 squared minus 2. So 13 is equal to a times, this will be a negative 3 squared minus 2. So that's going to become a positive 9a minus 2. I can add 2 to the other side. So I get 15 is equal to 9a. And I divide both sides by 9. Might seem a little bit weird, but it's totally fine to have a fraction here. So 15 ninths is equal to my a value. Okay, well, I could also reduce that. So let's do that. If I divide by 3, I get 5/3 for a. So that's totally fine to have that fraction. Looks a little bit different than we're used to, but it's okay. So my final answer is going to be the full equation now. So it's going to be 5/3 times x plus 1 squared, and then minus 2. Okay, I didn't ask for standard form here, so I'm just going to leave it like that. But just like before, you would expand out that x plus 1, multiply it, distribute it out, and then distribute the 5/3 and simplify. But that's it for today. So the biggest thing here is that we need 2 pieces of information to help us write the equation of a parabola. We need the vertex, and we need one other point that's on the graph. As long as we have those, we can use our vertex form, and if we need to transform it after that, we can. But that is it for today. It's a short one today. So take care, everyone, on that one, and good luck on that.